One important class of proteins are enzymes. So enzymes are protein. They are biological catalysts. They offer a new pathway that the reaction takes place with lower activation energy and faster. Sometimes they can increase rate of a reaction by a factor of 10,000. Now there are few properties for enzymes. The first is they are specific for a particular reaction. The pink is enzyme and this here is substrate which is attached to each other. The enzyme has specific shape that it can induce fit this substrate into itself, and then the reaction takes place, and this is your product. There is a separation here, and enzyme is released and comes back and starts over again. The second property of enzymes and the third are temperature and pH. Too cold, it doesn't work. Too hot, the enzyme is denatured. Too low or too high of a pH also causes denaturation of enzyme. If you look at this shape as represents a normal enzyme, it has a specific shape for active site that the substrate can fit into it. When the pH and heat are not normal, it gets denatured. Denature means it's destroyed. It's ineffective. You cannot use it again. So what is the optimum temperature and pH that you need to remember for enzyme activity? If you recall our body, the normal temperature is about 37 degrees Celsius. The pH of blood is about 7.4. And those are good numbers to remember as your optimum temperature. So when you increase the temperature of an enzyme, the reaction speeds up. Once it comes to 40 degrees Celsius, that's your optimum. If it goes above 40, then it's going to denature and it's going to become useless. And also us, we cannot function anymore. The pH of an enzyme is also this, about 7.4, 7.5 is the optimum pH that the enzyme can function its best. If you go too low or too high, it's denatured. And to talk about kinetics of enzymes, at beginning, the substrate concentration, the reactant concentration is going to be proportional to rate of reaction. The more you have, the faster it goes, because you have lots of enzymes that are available and this reaction goes fast. If you look at this curvature, the slope is dying off, and this is where the enzyme molecules are competing and we don't have enough of them. Eventually, all active sites of enzymes are saturated, and that's where you get the maximum rate or speed of the reaction. When there is no more enzyme, they're all saturated, so they come back to, once they produce a product, then they have to start over again. So there is always a maximum rate for a reaction that is enzyme dependent.